able to see my screen?
Yes.
Yeah, sure, sure. Yeah. So basically, let me start with the, what's AI. So basically, AI is a very broad field, and when I say very broad, I literally mean this because even if you are like 15 years or 20 years into it, you still can't understand what's going on, like fully, because it's exploding at a very fast pace. So but broadly speaking, like AI has like mainly two parts. Basically, one is machine learning, which is, so basically AI is not new. It's been there around like for the 1960s. People have been using something called machine learning and all. It basically uses statistics and everything. What you guys must be hearing is this something called deep learning. It's a new field. It just started, you can say, 7 8 years ago, and now it's exploding. Like it's taking over all of the industries and everything, right? So basically, these are the three fields, and if you have to start learning, people will directly throw you into deep learning. Don't just try to cover your basics from the scratch, right? Start from machine learning, and then deep learning, and then proceed over time. So basically, there are I would say three broader categories of machine learning. So basically, one is supervised learning. So basically, what supervised learning is, it's just like let's say you are a child, right? Your parents, that they show you a picture of an animal, then they say, okay, it's a dog. And then they show you another animal, they say it's a cat. So if you are shown enough examples of dogs and cats, automatically over time, after let's say 10 days or 1 year or whatever your age is, you learn that, okay, this is a cat, this is a dog, right? So this is basically supervised learning. You give some data. This data could be anything. This data could be a text, this data could be an image, or this data could be your personal data, like your age, your height, your weight, or whatever, depending on the use case, right? So you predict whether this is like true, false, or whether you are older, young, whether you will pass or fail. So basically, this tries to categorize things. On the other hand, regression is something which predicts a different thing. It predicts basically a real number, right? So instead of saying, okay, this is a cat or dog, you can predict, okay, what is the temperature. So you can see here, right? So how regression works is, you try to predict the actual number, basically. So you try to predict, given some data points. Okay, what was the weather yesterday, what is the highest temperature today. Given these data points, you try to predict what will be the temperature tomorrow. So if it's a real number, I mean, it's not real, but if it's an actual number, maybe 1.2 or 84, or like from minus infinity to plus infinity, anything, depending on your use case, it try to predict a number, basically, right? So you can say, okay, how much this stock will go up, right? So it will say, okay, 3 points, 4 points, 4 rupees, 5 rupees. Or the classification works basically on binning these things. Okay, will it be hot or cold? Will it be rainy or shiny? Will it be cloudy or not, right? So this is how it predicts. Basically, this is the only difference between regression and classification. There are like a lot of algorithms for those, but these are the broader categories, right? So this is the supervised learning. In unsupervised learning, what you try to do is, you don't have anything. We never show you the we call this a label, right? So in previous examples, we showed you, okay, this is a cat. We showed you a picture of cat, and we showed, okay, this is a cat, right? In unsupervised learning, we just give you a lot of pictures, right? So let's say you give 10 different shapes. Let's say you gave these three different colors to children. What they will do is, automatically they will sort these with green, red, and blue color, right? So this is called clustering. So it is in unsupervised manner. So nobody told you how to do it, but you did it somehow, right? So example of this in the real use cases, a cluster of your Facebook friends, or the people you follow. So the things you get recommended over time, over YouTube. So this is all a part of a clustering thing, that which they try to basically basically, let's say you are shopping somewhere, right? So they already have a your user profile based on like what are your shopping habits or like whatever. So if you go to Mintra or like Amazon or wherever, so they already have a user profile, and they have you clustered somewhere like this, depending on different use cases. This is a third part, reinforcement learning, which is I would say you might or might not encounter in your whole life. Basically, it's very advanced topic, and how it works is you try to teach something. So one example of this one is autonomous driving, right? So just like Tesla runs on its own, so this is how it was trained with this reinforcement learning. So this is how we Indian kids are being taught in the younger. So you do something bad, you get a punishment. You do something good, you get a treat, right? So this is how this reinforcement learning works. You are given a task, so if you do this badly, you are punished, or if you are excellent, you are given a treat or something like this. So this is how you train your dogs, or your these things, right? So this is reinforcement learning. So these are just some examples of how like what classification looks like. Basically, let's say these are the data point. So given this person's attributes, like what's the age, what's the gender, what's the where they belong to. Maybe they are from the Southeast Asia, or like Europe, or like wherever, right? So these are their data points. Given their data points, what's their height? So you try to predict the actual number. On the other hand, this is how you try to classify basically whether they are grown-ups or they are growing, right? They are older or younger, something like this. Basically, these are very simple uses, but everything I'll cover a lot of things going forward. This is clustering basically. This is cluster A. This doesn't mean that they specifically are grown or growing up. It could be like, okay, they are wearing black, they are wearing colored clothes, right? Maybe these two people are from Asia. These two are from like USA, or like wherever, right? So these are just clustering. You are clustering things in different categories. Another example of clustering is this one. So let's say you give kids or machine image of these entities, and they'll try to cluster looking at their properties, or like their how they look like, what's their color structure, or what they do. So as you can clearly see, okay, these are something which they fly, right? So that you can say, okay, you clustered all of these things which fly. These swim, right? And these are domesticated animals, right? So you can name however you want based on your use case, like what task you are working on. So these are the three broader categories. Uh, you know uh, what's the amazing part about this machine learning is it's very complex. To be honest, it's very complex, and people, they still, like after 20 years, there are a lot of legends in this field. Researchers, they are still working. They haven't fully understood this thing, but at the core of it, it's a very simple thing. It's a very simple thing. And when you were in I don't know if it's in still in 11th class or like 12th, there is a matrix multiplication, right? And I used to wonder, like, where do we use these matrix? I mean, why are we taught these matrix and everything? This is why we are taught matrix. Basically everything whichever I just shown you, everything, the whole AI part, right? The machine learning, the deep learning, the reinforcement, everything, this works on matrix multiplication basically, right? So let me just give you an example. Let's say these are two attributes of a student, right? These are, they are like four students, right? There are four students, and all of these are having both of these are having two attributes. Let's say how many hours they study, and what's their current level, right? So this is the attribute of first student, this is the attribute of second student. In the end, we are trying to predict whether they'll pass or fail, right? So it is as simple as that, right? So this could be, there could be like 1,000 attributes based on how complex your system is, or for starters, it's just two attributes. I just said this first attribute is how many hours they study, and what's their current level of on the education, and I'm trying to predict whether they'll pass. So if this is high and this is low, it means that they'll pass. If this is high, this is low, it means that they'll fail basically. And if you look at these things, right, if you can recall the matrix multiplication, so this is 4 by 2 and this is 2 by 3, so the multiplication will give you 4 by 3 matrix, right? So this is what happens. Again, there is another matrix which get multiplied, and in the end, which gives you the attribute for first student, second student, third, and fourth. Similarly, we'll get a prediction of whether they'll pass or fail, right? So this is a very very I'll say wrapped up example. It is much more complex than that, but at the core of it, it's all like algebra and your matrix multiplication. When you go to deep learning, there's a bit of calculus also, but don't get intimidated. You'll learn everything as you go down, right? So there's another field of AI which is at a boom these days. Basically, it's the generative AI. So I'm sure each and every one of you might have heard about something called chat gpt, right? So it's a generative model, so it generates something for you, and that something is a text. Basically, you ask chat gpt to write something for you and it will write. So similarly, it is not the only model in the world. Basically, it's the most popular one. So you can use this generative AI to basically whatever I just explained here. This is all called predictive AI, right? So you do the prediction for future. For this one, it also does the prediction, but in a different manner. So we call it generative AI. So basically, it generates. It can generate text for you, it can generate images for you, it can generate audio, video, like whatever you want, whatever you can think of. And it's not that it will generate text from text, right? You can give it an image and it will generate text for you. You can give it a text, it will generate image for you, and vice versa. There can be a lot of combinations. You can give two things, three things, four things, something like this, right? So yeah, so basically for this project to run, you just have to do this, right? You just have to click on this one. If I do it, it will take a lot of time, because these are all dependencies and everything. For right now, don't get bothered with the code, with the amount of code, and it is very very basic code, to be honest. And if you don't know Python, you might get a bit uneasy, but there is trust me, there is no not a single thing that you won't learn if you start working with it. Basically, this is all just Python code. You don't have to worry about it. If you go further in your education and everything, you'll just learn it, right? So basically, with this example, that what I'm trying to do is this is just a fun example, right? So I got this like this image from this URL, right? And what I'm trying to do is I'm just trying to manipulate it, right? And there are generative models for images also, right? And for these, your imagination is the only limit. So whatever you can imagine, right? So I just forced like a model to to implement something like this, right? So I'm forcing for the same image, right? I'm forcing it to eat a vegan burger, like in a subway, wearing Lakers jersey and a bandana, right? So so it's wearing everything whatever I ask the model to put anything on it. So if you change this thing, right, it is something called prompt, right? So you force the model to create something out of something. So basically, in this case, something is our original image, and I just manipulated it with this one. So you don't have to be a UI UX artist, or like a Photoshop expert to create these kind of images, right? So this is one example of giving two inputs. Basically, one was this image and another was the prompt, right? So I gave it an image and a text, and it generated a modified version of my image, right? So if you go to next one, right? So this model is specifically trained for Pikachu, right? So you can ask it to create any kind of Pikachu, right? So maybe it's a fight, it's fighting another Pikachu. I just asked it to it's jumping and standing on a like a big stone, like. And if you can see, there's a sunrise, right? So there's a sunrise, and it's very realistic. If you can see, I didn't have to work hard to create this image, right? So if any one of you have seen this new movies in recent times, so all of them when they start their credits, they use these kind of models to generate animation and everything. So with these kind of things in a loop, you can generate a whole movie basically, right? So you can generate a whole movie and you don't need to draw a single picture basically, right?